Probability diagrams. A container contains 30 green tokens, 15 blue tokens, and 3 red tokens. 2 tokens are randomly selected without replacement. Compute the probability of F given E. E is the event that we select a red token first, and F is the event that the second token is blue. First, we want to find the probability of E. This is the probability of selecting a red token first. And this is found by taking the number of red tokens and dividing it by the number of total tokens. So the number of red tokens is 3. And then the number of all tokens is found by adding 30 plus 15 plus 3. And 30 plus 15 plus 3 is 48. So the probability of event E is 3 over 48. Now, we're asked to find the probability of F given that E already occurred. So we want to find the probability that the second token is blue given that the first token was red. In order to find this, I'm going to create a probability diagram, which is a tree diagram but with probabilities. So I'll first create the tree by writing down the probability of selecting the first event, which is a red token. And that's 3 out of 48. And again, this represents my first selection. Now, I need to draw branches for the options of my second selection. So I could either draw a green token on my second selection, I could draw a blue token on my second selection, or I could draw another red token on my second selection. Now, I'm only concerned with my second token being blue. So I'm only going to list the probability of this middle branch here. Now, my first probability was 3 out of 48. My second probability is going to be the number of blue tokens over the number of tokens left in the container. And remember, I'm not replacing any of the tokens. So when I first selected the red token on my first selection, I didn't replace that token back in the container. So there's only 47 tokens left in the container to choose from. So my denominator is 47. My numerator is the number of blue tokens that are left. And since I selected red tokens on my first selection, that means that all the blue tokens should still be in the container. So there are 15 blue tokens left. So my probability is 15 over 47. And this is my final answer because I included the condition of selecting a red token first. So the 15 over 47 represents the probability of selecting a blue given we already selected a red without replacement. We roll a pair of dice 4 times. Find the probability that a total of 5 is rolled each time. We're going to use the concept of the fundamental counting principle learned in Unit 5 of the course to solve this problem. But instead of multiplying the number of tasks together, we're going to multiply the probabilities of each task together. So since I have a pair of dice being rolled 4 times, I have 4 different probabilities. And I'm going to multiply the probability of each event occurring to each other. So we want to find the probability of getting a total of 5 each time. So the first box will represent rolling a total of 5. The second box will represent the probability of rolling a total of 5, and that will be true for the third and fourth boxes as well. So now all I have to do is find the probability of rolling a total of 5. And we'll just create a chart again. And then the rows and columns represent the 6 sides of the dice. And then we're just going to find the sum of the dice by adding the digits together. I have all my possible outcomes of sums in the chart, and I'll just identify the number of times that 5 occurs, and that's 4 times. So my probability of rolling a 5 is 4 out of 36. And 4 over 36 can be reduced by dividing both the top and bottom by 4. So 4 divided by 4 is 1, and then 36 divided by 4 is 9. So the probability of rolling a 5 is 1/9. So I'll just include the 1/9 inside my boxes that I have, and then we'll just multiply 1/9 to itself 4 times. 1/9 times 1/9 times 1/9 times 1/9 gives us 1 over 6,561. So the probability that a total of 5 appears each time when we roll a pair of dice 4 times is 1 over 6,561. Find the probability of the intersection of N and R associated with the tree diagram. What is the probability of N intersection R? We'll use the multiplication rule for probability, which says that the probability of the intersection of N and R equals the probability of N times the probability of R given N. First, we'll look at our tree diagram to identify the probability of N. N is the middle branch, and the probability is 0.4. So the probability of N is 0.4. Now we'll multiply that to the probability of R given N. This is the event that R occurs given that N already occurred. So, to find this probability, we're first going to locate event N because that occurred first before event R. So here's event N, and then R occurred. So from N, we want to go to branch R, which is this branch here. And the probability is 0.7. That 0.7 represents the probability of R given N. Now, to find our answer, we're going to multiply 0.4 times 0.7. And that equals 0.28. So the probability of the intersection of N and R is 0.28.